Dear students, today I am going to take up the topic atomic structure. All the topics of chemistry are based on this. It is very important topic. In this topic, different atomic models we discuss. The very form of the matter we ultimately discuss. If we see the matter, we can divide into small particles and we end up with the small particles called atoms. Further, we cannot divide. They say that the atoms are the building blocks of matter. This type of discrete, discontinuous nature of matter was first pronounced in the 5th century BC by a Greek philosopher named Democritus. He mentioned the term atomos. It means uncuttable or indivisible. A contemporary Indian philosopher, Marsh Kannad, also expressed the same opinion of Paramanu. Paramanu means ultimate form of the matter. Uh, until 1808, there was no scientific progress regarding this discontinuous nature of matter. In 1808, John Dalton proposed theory. It is called John Dalton's theory, in which certain postulates are mentioned and explained. One, each element is composed of extremely small indivisible particles called atoms. Atoms of a particular element are alike or identical. Atoms of one element are different from another element. Atoms of an element are the building blocks. And here they have characteristic property like mass. Atoms take part in the chemical reaction by means of the combination, separation, and rearrangements. And during chemical reactions, mass can neither be created nor destroyed. That's what he mentioned. Mass can neither be created nor destroyed. Mass remains same. With this, the very elementary idea of matter, discrete nature of matter, then one important thing we have to notice regarding the John Dalton atomic theory. He said indivisible or uncuttable, but they are cuttable, they are divisible into the subatomic particles like electron, proton, neutron, and some other 30 odd particles. All are said to be the subatomic particles. Now they are divisible. So that is the uh, limited. That is the biggest mistake of John Dalton theory. They are divisible, but he mentioned indivisible nature. Though they are invisible nature, but they are divisible. So this divisible nature was first perceived by certain scientists and explained by some other scientists. If you really go back to the history of chemistry, in 1830 itself, uh, Faraday conducted the electrolysis, that is through aqueous medium. When current is passed, the electrolysis process takes place, splitting of the chemicals in the aqueous medium, electrolysis. Here, without knowing the very basic nature of electrons, he proposed two theories: Faraday's first law, Faraday's second law. As on today, they are still valid. But later, the Stoney, scientist called Stoney, mentioned the term electron, the charged particle which are responsible for conducting of electricity, or electron. He mentioned the term electrons. Later on, J.J. Thomson conducted discharge tube experiments. In the discharge tube, the purpose of conducting discharge tube experiments only to know the conducting behavior of different gases. Conducting behavior of different gases. I said very purpose of conducting this experiment was only to know the conducting behavior of gases at different pressures and different voltage which is applied. The experiment was quite simple. Take the glass tube of this kind, keep the electrodes. Electrodes. Yes. So this is here is the exhaust connected to exhaust pump. This is anode. This is cathode. High voltage applied. Here gas, any gas which is placed. This was a simple experimental setup. The pressure of the gas inside is controlled by the exhaust pump. So here this is the positive charge, this is the negative charge, and while here to check whether gas allows the conducting behavior of current, that we can check with the galvanometer which is placed in the series. Now normal conditions of 1 atmosphere and voltage like 10,000 volts, 10,000 volts applied. There is no deflection in galvanometer saying that gas exhibits the bad conducting nature. But once we go on decrease the pressure up to 10 power minus 2 atmospheres, then it starts in glowing of this tube. Further decreasing of pressure up to 10 power minus 4 atmospheres. At this stage of high voltage and very low pressure, here the gas in the tube, one thing we can notice, rays are set, these rays are appearing. The rays appear to come out from the surface of cathode and moving towards the anode, hence these are said to be the cathode rays. The very nature of these rays are, one is they move in this direction, cathode to anode, and if any opaque body is placed, shadow is formed, indicating the travel in straight path. This traveling in straight path. Travel in straight path. That we can infer from the opaque body, a shadow is formed behind it. And the second thing is, if electric field is placed, they bend towards the positive charge plate, indicating that they have negative charge. And magnetic field is placed, they bend towards the north pole, indicating same thing, that these are the charged rays. And third one is these rays are material rays, that we can confirm with the help of a paddle, a small light paddle is placed in the path of these rays, say this wheel gets rotated. This wheel gets rotated if this paddle or wheel is placed in the path of these rays, it gets rotated. That is a mechanical event, saying that these are not simple rays, they are the particle rays. These are the particle rays. Thomson himself found charge to mass ratio of these rays E by M ratio, that is charge to mass ratio 7.6 into 10 power 8 coulomb per gram. 1 gram of mass of these objects, these electrons, is associated with a 7.6 in 10 power 8 coulombs. And later on, the charge of each particle was determined by Millikan by his oil drop experiment as 1.6 into 10 power minus 19 coulombs. So from these two informations, charge to mass ratio, this means 7.6 into 10 power 8 coulombs is associated with 1 gram, and 1.6 into 10 power minus 19 coulombs associated with 9.11 into 10 power minus 28 grams. So later on, these particles, these cathode rays are the stream of particles. These stream of particles are nothing but the electrons, and the electron mass is this very minute 9.11 in 10 power minus 28 grams, and its charge is 1.6 into 10 power minus 19, that is the negative charge, the charge to mass ratio. In this experiment, any gas which will take in the discharge tube and conduct the experiment under the conditions high voltage and low pressure, and the same cathode rays are witnessed, the charge to mass ratio found to be same. This observation clearly says that every object has mass. Suppose in this case hydrogen gas is taken, the type of mechanism which we propose is this. Hydrogen gas, which exists in the molecular state H2, first it splits into hydrogen atoms. So hydrogen atoms from which we are supplying energy in the form of voltage, these get ionized. Hydrogen atoms get ionized, and this electrons set in the form of rays called cathode rays. Here you can ask one thing, here positively charged particles are which are also there, but with this simple setup, those rays are not found that we can discuss in the anode rays, that is for the discovery of the proton. Now in this case, if hydrogen gas is taken, this type of explanation we can give. If helium gas is taken, what we can say that the helium in the exists in the atomic state, energy which we supply in the form of voltage, and so that is the ionization takes place. Further, it has one more electron, He2 plus, and one more electron. These are set in the form of this. So E by M ratio is same, irrespective of the gas which we take in the discharge tube. That's how the discovery of electrons was made by the J.J. Thomson. The nature of electron is a negative charge, very minute in nature, and without electrons, matter doesn't exist. That type of conclusion we can make it. So in the next class, which we'll discuss the discovery of proton, discovery of neutron, then we'll go to the atomic structure chapter.